We are solving a NEET 2019 question. It's from two-dimensional motion. Let us read what the problem is. An object is shot from the bottom of a long, smooth inclined plane, kept an angle 60 degrees with the horizontal. It travels a distance x1 along the plane. Let us stop there for a minute and see what he's trying to tell you and how do we interpret it, right? So he's saying that there is an inclined plane, a long inclined plane of some inclination. Let's assume the inclination equal to theta. An object is shot from the bottom of the long smooth inclined plane at an angle. It can travel a distance x along the plane, along the inclined plane. That means it is going to travel a distance x. What do you mean by it can travel only along a distance x? Means here it is going to stop. It's going to stop there, right? Object is shot from the bottom with a velocity u and it is stopped here, right? So what are the forces acting when the object is somewhere in the journey is a very interesting question that we need to write. This object is definitely having some mass, so its weight will be always acting in a downward direction. This can be resolved into components. You have learned that this is theta, this is also theta. So this becomes mg cos theta. This becomes this force, the downward direction becomes mg sin theta. This mg cos theta creates a normal reaction that is not that relevant to this problem. Only important thing that we can notice is the force acting down the inclined plane against its motion is mg sin theta. Once if we understand that, we can write force down along the inclined plane F equal to mg sin theta. Right? It's smooth, so no friction need to be considered. If you want to know acceleration, you can equate that to ma. That implies acceleration in this case equal to a equal to g sin theta. The body is having an acceleration of g sin theta against the motion. So I can use the equations v square minus u square equal to 2as. It is stopped. U along the inclined plane itself, that was given for u square. A equal to, I will write minus g sin theta because it is against the motion. You are trying to move up in the plane and g sin theta is acting against it. S is equal to x. So u square equal to 2 sin theta into x. Minus and minus will cancel. So x equal to u square by 2g sin theta. That's an important observation that we need to make before we proceed and read what is given in the problem. But when the inclination is decreased to 30, the same object is shot with the same velocity. It can travel through a distance x2. So what happens when the angle changes is the question, right? So you can, as you have got x equal to u square by 2g sin theta. It is said that it is same velocity. 2g is anyway constant. So how much distance it travels along the inclined plane is inversely proportional to sin theta. So I can write x1 by x2 equal to sin theta 2 by sin theta 1. Sin theta 2 in the second case is 30 degree. In the first case, angle is given as 60 degree. Sin 30 is half, sin 60 is root 3 by 2. So the ratio is 1 is to root 3. So the answer is 1 is to root 3. That is that simple. To solve this problem, we need to know this concept that how do we resolve this mg into components. That's the most important thing, that we resolve this mg into components. One is the adjacent component mg, because we have done this in friction also, and the component parallel to inclined plane is mg sin theta, who is acting against the motion and trying to stop that body, and that's why it is stopped somewhere. The final velocity is 0. Thus we got an answer 1 is to root 3. That's it. Thank you for watching. This is the answer 1 is to root 3.